Anyone who sees the footage of particularly the immediate aftermath of the train disaster, obviously it's enough to get your attention whether you're a scientist or not. When you see huge plumes of black smoke emanating from these cars that are off of the track, immediately you begin to think about, was someone on the train injured? You begin to think about what's the source of that black smoke. Begin to think about human implications as well as environmental implications. Who lives in that area? How close are they to this? But then ultimately you begin to think about what was in those tanks. What does that hold or foretell in terms of potential environmental impacts? And of course, as a scientist, it causes me to go to specific areas, particularly what class of chemicals might have been in there. What type of ecosystem is this where this spill occurred? You know, again, thinking about the potential outcomes, we immediately as humans, of course, we think about the human costs, and understandably so. I have a family. I want to know that my family is safe if I live near a train track or near a pipeline, etc. But when accidents occur, and have no doubt, as safe as we want to be and as many regulations as we have, there's still the potential for significant, accidents and environmental disasters to occur. The question then becomes, how do we deal with them? How do we learn from this to hopefully prevent these types of accidents from occurring in the future? And it causes us also to double down on the understanding that we are part of an environment. We cannot separate ourselves from the environment. We're part of the ecosystem. We have a role, we have a responsibility in how we protect and interact with our ecosystem, but we're also part of it. It's kind of the old canary in the coal mine adage from our coal mining days. If there's a spill that affects fish, if it affects livestock, if it affects other types of animals, then of course we need to be concerned about what the potential effects might be on us. So I think about it in those at least a couple of different ways. First, as a regular everyday citizen of the planet, but then secondly, as a scientist, as an environmental biologist, and thinking what are those potential effects. So when I look at a train going down the road, there are labels on each of those cars that indicate what level of risk, aerosolization, getting aerosoled into the air. Is it a risk for, is it flammable? Is it combustible? And those two things aren't even the same. So we label these cars. In the case of East Palestine, unfortunately, we're not talking about a case of spilled milk here. And I mention that because a lot of times train cars are hauling relatively harmless materials. It could be food, it could be rocks, it could be gravel, it could be coal, it could be milk. It could literally be milk. But it could also be volatile chemicals and require a different kind of response because of the risk that they pose. While they're safe in that container and if handled appropriately, they weren't designed to be exploded or combusted or crashed off of train tracks, and that's what's happened there, unfortunately. The primary chemical here is something called vinyl chloride. And vinyl chloride is a substance that is a primary component of plastics. That is, in the formation of heavy plastics like PVC. Vinyl chloride itself is a nasty product. Vinyl chloride, when combusted, forms other chemicals that can become airborne and can become a problem for us. I wrote the main one down here. It's called phosgene. And that's the problem with these chemicals. They don't always stay in the same state. All of a sudden now we're dealing with an airborne pollutant. Or if not combusted, maybe it finds its way to a waterway. And the problem with this chemical when it comes into contact with water is it converts to something called hydrochloric acid. That doesn't sound good, yeah, and it's not good. The good thing is it has a very short, what we call half-life. So that means it doesn't survive very long. One molecule of it doesn't have a long survival in the air. That's great. That is actually very good. Of course, how long it stays in the air depends on how long it's being released and how long it's being burned and so forth. And if you are in immediate proximity to that, you could still get exposed to it. And that spells problems for us in terms of our respiratory system. It's a carcinogen. Those are all issues that we're concerned about. Most of the experts, I actually listened to an expert last night on a podcast who is a well-known environmental toxicologist, said that the vast majority of the phosgene aspect of this spill that was combusted and seen in this burning smoke, and even in what was done later, and this was why it was done, as a controlled burn, you may have heard that. Yeah. We had some cars there that still had some leaking out, and the decision was made to do a controlled burn. Now around here we think of a controlled burn when we are burning native grasses to make them prosper. But in this case, the reason that was being done is when that transformed to phosgene, it had a much shorter time in the environment before it broke down. This particular expert that I was listening to, that probably within a matter of hours and at the extreme, a day and a half, more or less the period of time over which that burn occurred, that would have dissipated and no longer been detectable in the air of that community. So that's good news. Here's the bad news. It also shows you why these chemicals were not intended to be spilled in an uncontrolled way in a disaster like this. I'll introduce another term to you here called a thermal inversion. And unfortunately in this area there actually was this phenomena taking place during this spill. A thermal inversion is a situation where you have an area of warm air on the ground, but you have a change in the climate where you get some cold air. You hear about fronts where our cold air overflowing. In this case, we had a situation where cold air was overflowing the warm air. Well, if cold air is above warm air, what does warm air want to do? Warm air wants to rise, which would distribute or disperse. Could be a bad thing. If it's a chemical that had a long life, it could disperse and affect lots of other communities. But if it has a short life and you want it to disperse in the air to be able to get rid of that chemical or have it disperse rapidly and run its course, thank you, that could be thought of as a positive if you can find a positive in this event. But it couldn't do that because the cold air wants to do what? It wants to sink. So yes, it's pushing and holding that warm air down. And what that's doing is exposing the environment at the ground level over a much longer period of time, and the people that might have been in that area, that's why it was so critical they be evacuated so rapidly. So having a thermal inversion, it's a real nasty situation where you have chemicals being introduced. Insect dispersants like for bed bugs or for fleas or for wasps or other things. They tell you to open the windows soon after and not be in there while it's going off, of course. One of the most noteworthy examples of a thermal inversion that had deadly impacts in the United States happened in 1948 in one of our manufacturing centers of the U.S. in Pennsylvania. There was a zinc smelting plant there, and that plant, it was known to create a fog, a yellowish fog. People kind of got used to it and maybe didn't even know what it was, and they're breathing it in all these years. In 1948, however, there was a particularly serious thermal inversion that happened, and exactly what we just described. And in the areas around this zinc smelting plant, that outflow from the smelting plants, from those smokestacks, had nowhere to go. And for days it was trapped down against the ground, exposing humans. And days went by before we recognized we have a problem. People began coughing, they couldn't breathe, they had lots of asthma-like symptoms, and it resulted in a number of deaths. So that's what a thermal inversion can do. So the other issue we've seen that kind of sent us some red flags with this vinyl chloride product, we talked about it off camera a little bit, was you had seen, I think, some footage. I saw a little bit of this footage of some of the local streams. Showed some folks in the stream stirring up the bottom of the stream, and then seeing deceased fish, of course, belly up there, which tells us we did have a fish kill associated with it. It was several thousand fish, as we know, in some of the local streams. The fish kill is most likely due to a crash in oxygen in those streams as those chemicals began to wash into the streams. Suffocated the fish, essentially. and reduce the oxygen availability in those streams. That's probably what more directly led to the hydrochloric acid part itself. Probably wasn't toxic to the fish. It was probably the result of a decrease in oxygen availability that ended up getting those fish, which oftentimes is the case with a fish kill, a chemical or something else being dumped into a body of water like livestock waste or something else decomposing in the water. Bacteria come in and they multiply rapidly and consume all of the oxygen, and then it results in a fish kill. So that, of course, gets our attention, because then we think, well, what might be happening in our water sources for the humans? So the big emphasis you're seeing right now with the officials on the ground there, the scientists on the ground and others, still recommending, I think, that local folks have their private wells tested to confirm that they're safe. We've already tested, I think, all of the municipal water supplies, and even the surface waters are testing clean now. So that's definitely a good thing. But what you can't see can hurt you.